So, sorting. Sorting refers to arranging your data in a particular format, maybe incrementing, decrementing, some mathematical formulas, whatever it is, it's arranged in a particular format. The sorting algorithm specifies the way to arrange data in a particular order. For example, telephonic directory and dictionary. In the dictionary, everything is arranged in the alphabetic order, and the telephone directory also it is in the alphabetic order. If you want to say sorting means just go on the yes order, yes please, and then O, yes O, RT. So after that we have to search there. So it keeps on sorting like this. This is what happens in the sorting algorithms. And there's types of sorting algorithm: in place sorting algorithm and non in place sorting algorithm. So in place sorting algorithm means the sorting happens only in the place already present. So there is no need of extra space. The elements are in a particular memory space. It is using the same memory for sorting algorithms or sorting purpose. There is no extra memory or other place of memory. Only the place where the already existing, already the elements are placed. So non-in-place sorting algorithms. It uses extra memory, other places. This is what is called non-in-place sorting algorithm. Unstable algorithm means the sequence doesn't changes. The sequence changes, it is called non-stable sorting. For sequence changes means if, for example, 1 2 3 3 4 5 6. So in stable algorithm means the first three will be placed first and second three will be placed second. This is what is called stable. Non-stable means for the 3 3 3, maybe the fourth three in the 3% the fourth place will be placed in third, and the third 3% the third place will be placed fourth. That's not an issue. The place is not important. Only the elements are sorted or not, it's the main concern. Okay, so adaptive and non-adaptive algorithm. Adaptive in the sense, use all the sorted elements and sort only the unsorted element. If there is already sorted means no problem. If some elements are sorted and other elements are not sorted means it will discard the sorted elements, sort only the unsorted elements. For example, 1 2 3, the next three elements, that is 6 5 4. For 1 2 3 it will not sort. 4 5 4 6, it will sort only three elements. Okay, so non-adaptive means sense it sort each and every element, whether it is sorted or not. It's once again go on the sorting process and it keeps on going, and finally it's sorted, you get the sorted result. So increasing, non-increasing, decreasing, non-increasing. That's the name. Plus sorting is happens by means of increasing format. Non-increasing, it's not an issue for non-increasing. Decreasing, non-decreasing. Okay. So for examples, we are having to say something about insertion sort. Insertion sort, it is a place comparison based sorting algorithm. Here a sublist is maintained which is always sorted. An element which is to be inserted in the sorted sublist has to be find its appropriate place and it is inserted there. An algorithm is not suitable for a large set of data because its worst case scenario is order of n power 2. The n is the number of elements of sorted to be sorted. Okay, I will see by means of example and then it will be easy for you to understand. For example, 14, 32, 13, 14, 33, 27, 10. This is unsorted array, linear unsorted array. So first we compare 14 and 13. 14 and 13, it's already sorted. In the ascending order, 14 is placed in the first place, 33 is greater than 14, so it's placed in second place. So it's already sorted. This is a sublist, one sublist. It's sorted. So next we go for 14, 23, and 27. This is unsorted. So 30, 33 and 27 is uncertain, so we compare 33 and 27, then changes to 14, 27 and 33. So this is another sublist. So this is sorted. First three elements are sorted, that is 14, 27, 30. As per these elements, it's sorted. So next we go for the next element, that is 14, 27, 30 and 10. For this is not in a sorted order, so we have to compare the 10 to 13. So 30, 33 is greater than 10, so we have to change the places. So this happens, that is 33, 10 will be interchangeable. And next we have to sort this 10 compared to 10 and 27. This is not sorted, so I have to change the location 10, 10 and 27. So next, it's not sorted, 10 and 14 are not sorted, so we have to compare it 10 and 14, and 10 will be placed here, 14, 27, 33. So for the first four elements, it's in the sorted format. So this whole process, so till the final result, we have to do this again and again till we got the sorted elements. This is what happens in the insertion sort. We insert the element in a particular place where it belongs. This is what is called an insertion sort. We can't able to use it in a large set of data. Okay, algorithm. So step 1, if it is the first element, it is already sorted. Then what? Pick the next element. Compare with all elements sorted sublist. Sublist means this is a sorted sublist. So what is the sorted sublist means? If first, so what next? 14, 27, 30 and 10. 13, 33 is the one subset. Now we are going to compare with 10. We are including 10. If 10 is added, it is not a sorted sublist. So we have to alter it from 33 to 10, 10 with 27, 27 to 14, 47, 14 will be replaced with 10. Then the final result will be 10, 14, 27 and 33. Okay, this will keeps on going till we get the sorted elements. Okay, so next we're going to see about something about merge sort. Merge sort is sorting technique based on divide and conquer techniques. We have to divide the elements and conquer it back. Okay, the worst case scenario is order of n log n, so it's the most respected algorithm. So how it works, we will say by means of some example: 14, 33, 27, 10, 35, 19, 42, 44. So first it will be divided into two. 14, 33, 27, 10 will be one subset, and 35, 90, 42, 44 are the next subset. Okay, so again divided the subset into two, that is this one, this one, this one, this one. So again divided 2, 2, 2. So each element will be divided in the single subset. So I have to merge it one, that is merge it by minus sorted one. 14 and 30 sorted, already sorted. 10, 27 and 10 it's not sorted, so we have to interchange it 10 and 27, and 19 and 35 it's not sorted, so sort it out 19 and 35, and 42 and 44 is sorted, so it's placed like this. So next combine this and produce this 10, 14, 33 and 27. Okay, after sorting, we get 10, 14, 19, 27, 33, 35, 14, 42, 20, 44. This is what is happening. First divide into 2 and divide into 2, 2, 2 till we get an individual element, and then we compare with the nearest element and then merge it again and again till we get the result, sorted result. So merge sort keeps on dividing the list into two equal halves until it can no more be divided. By definition, if it is only one element in the list, it is sorted. Then merge sort combines the smaller sorted list, keeps a new list sorted. So, okay. Step 1. If it is only one element in the list, it is already sorted. Return. Divide the list recursively into two halves until it can no more be divided. So merge the smaller list into new list into a sorted order. Okay, I mentioned it. So next, quick sum. It's a highly effective sorting algorithm. Divide the array by using a pivot. So value of pivot is near to the middle value, where one side contains a lower and the side contains a higher value. Quicker records calls itself for the sub arrays to sort. Okay. Now consider by means of explaining the example will be very easy for you to understand. So first, this is a sorted. This is largest element is 42, so we have to find the middle element 10 and 42. So middle element will be around 31. This is what generally happens. So we have a formulas. So choose the highest index value as pivot. Take two variables and left point left and right less exclusively. Left points lower index, right points to the highest. So next, okay, this pivot example. So first, giving a pivot 31. So first 31 is a pivot. The left side it has a lower value subset, right side it has a lower value subset. So in the next subset we have to find another pivot, that is for example here 10, 10, 14, 19, 27 and 26. So think about 19 is the pivot for this subset. So 10, 14 will be in the left side and 26 and 27 will be right side. So when compared to this, so the 10 and 14 already sorted and 26, 26 also already sorted. So there's no other changing it. And next in this subset, that is 42, 33, 44, 45, just check it at 35 as a pivot, then 33 in the left, 42 and 44 in the right. So 33 will be already in single element, it's sorted, 35 will be pivot, and the next 42 and 44 will sorted. So this is what happens in the quick sort algorithm. So make the right portion text value pivot, partition the array using pivot value, quick sort left portion recursively, quick sort right portion recursively. So the same step will be followed, that is finding a pivot. Higher value will be in the right side and lower value will be in the left side. Keeps on going till we got the sorted elements. Okay.